So this video discusses about the addition and subtraction of the matrices. So when are we entitled to add or subtract two or more matrices? So the matrices, two or more matrices can be added if they are of the same order. So in this case, let's say we have a matrix A that is given as M over N. Actually it should be M down N or down P in this case. And let's say we have another matrix, let's say matrix B, that is being given as, let's say, X, Y, Z, let's say W. Now these matrices are of the same order, hence can be added or subtracted. So the addition of the two matrices, this is also the same as M down N or P and a plus X down Y, Z down W. So these matrices has to be added complementary. We'll have M plus X, that will be given as MX, that is given as M plus X, and also O plus Z, that is given as O plus Z, and N plus Y will be given as N plus Y, and the P plus W, that will be given as P plus W. So this is how we can be able to add these matrices, and provided they are of the same should be order. And likewise, if we are to subtract, it means we'll have the subtraction here. That should be the case. Now let's say we have the following matrices. Think about this. Let's say we have the matrices. Let's say we have the matrices given as A, which is being given as, let's say, 3 and down 4. We have 7, 6. By the way, the brackets can be actually closed brackets or just the way we are having those. Let's say we have the matrix B, that is being given as, and that should be 4, 8, and the negative 2, and there should be 2 here, like this. Now evaluate the from, let's say A, we should have the matrix A plus matrix B. So in this case we need to add these matrices complementary, so which means we'll have it as, it should be like this. Let me present it here, and it should look something presentable. So in this case we'll have the matrix 3 down 4 and 7 down 6 being added to, that is 4 down negative 6, should be negative 2, and 8 down 2, like that. In this case this is the same as having 3 plus 4, that is being given as 7, and 7 plus 8, that is given as 15, and our 4 should be 7 plus 8, that is 15, and 4 plus negative 2, we have it as positive 2, and 6 plus 2, that is 8. So this is how we can have it. And likewise B, we are looking for the subtraction of, let's say, B minus A. So in this case we'll have the matrix B, that is 4, negative 2, 8, 2, and that is minus, we have 3, 4, and 7, 6, like that. So in this case we'll have it as 4 minus 3, that is given as 1, 8 minus 7, that is given as the negative, should be positive 1, like that. And the negative 2 minus should be 4, we have negative 6, and the 2 minus 6, that is being given as the negative 4. So that is the solution. So by now you know how we can be able to add or subtract matrices in that way. And also let's say we have the matrix Y, that is being given as 0, 2, 1 7 82. Let's say that is the case, and we have a matrix X that is being given as, let's say, 2 4 8 8 7 1, like that. And let's say have the matrix P that is given as 1 1 0 1 0 1. Let's say that is the case. So evaluate the following. Let's say we have X plus Y plus B, and let's say we should have, X minus P minus Y. We should have that. And let's say we should have, there should be C here. Let's say we should have B, plus X minus Y. We should have it. So how should you have this? So try to express those. That is on your own. And now let's say if we have this case, let's say we have the matrices that is 2, 4 3 A, like that, and minus, let's say B 6, and that should be C down 4, and which is equal to, we have 3, and D 4 down 7. Let's say this is the case. But now, before we go further for this, I want to explain something for you. Let's say if we have the matrix A that is being given as X down Y M down N. Let's say this is the case, and we have the matrix B that is being given as, let's say, Q P K, let's say R. Let's say this is the case. Now, assuming that the matrix A is the same as the matrix B, so what does this one mean? So in this case, this is the same as having the matrix X down Y M down N, it's the same as having it as Q P K down R. So in this case, actually these matrices are the same componentry. So in this case, we use what we call as the equivalent theorem. So what is the equivalent theorem? According to the principles behind, so the stage that we are at now, in this case, we have the matrices of the same order in both sides. We have, 2 by 2 matrices, should be 2 by 2 matrix, and also this is the 2 by 2 matrix. So if A is the same as B, it means X is the same as Q, and M is the same as K, and Y is the same as P, and the N is the same as R. This is what we call as the equivalent theorem. So how about, let's say, if we have this case? Let's say we have the matrix, let's say, given as M, that is being given as, let's say, 2 0 1 5, and let's say we have the matrix N that is being given as X, M, and let's say D. Let's say this is the case. Now, given that the matrix M is the same as the N, so find the values of X, Y should be X, M, N, as well as the D. So in this case, we use the equivalent theorem. So that will be given as, we have 2 down 0 1 5, like that, and which is the same as X, M, N down D in this case. So now we have 2 is equal to X, therefore X is equal to 2. We have N is equal to 1, M is equal to 0, and 5 is the same as D. So that's how we can use the equivalent method, equivalent theorem, in order to have that kind of a situation. Now in this case, how should you have the values of B, C, as well as the D, and also A in the following problem? So as you can see, first thing, we should have to ensure that we have 2 by 2 matrix as we have with this side. So which means this is the side we should have to deal with first. So this is the side we should have to deal with first before we go for the other side. So in this case, these matrices are actually subtracting. So in this case, we'll have 2 minus B that is given as 2 minus B, since they are like terms. So 4 minus C, that is 4 minus C. and 3 minus 6 we have negative 3, and a minus 4, that is a minus 4. Now we have 2 by 2 matrices. Matrix that will be given as 3 down D and 4 down 7. So in this case we use the equivalent actually theorem that will be given as 2 minus B is equal to 3. So in this case we'll have 2 minus 3 is equal to B. Now what is the B here? We have it as the negative 1. And likewise we can also have negative 3 is equal to D. So in this case D is given as the negative 3. And a minus actually 4 minus actually A minus 4 is equal to 7. So in this case A is the same as, and that should be 11. Likewise we can also have C, which is the same as this. And that should be which is the same as this. So that is how you can make use of the equivalent method. It should be theorem in order to find the unknown variables if we have the matrices in that way. And sometimes you can also have this case. Let's say you have we have M down 7, we have let's say 2M and down let's say 6N. Maybe you should have 7M here, you should have 6N, and we should have 2M here. Let's say it should be this, and should be given as, let's say have 2M, now should be 2 down 5, let's say 0 down 7. So in this case we should have by the way, let me have it in this way, and for the global orientation, and I should give the real sense as well. Let's say have M plus 2N and 7M minus let's say 6N. Let's say this is the case, and I wish to solve for the values of M as well as the N. So in this case this is should be 2 by 1 matrix, and also this is 2 by 1 matrix. They're of the same order. So using the equivalent theorem we'll have M plus 2N, which is equal to 2. That is equation 1, since M as well as the N are actually the known variables. So have 7M minus 6N, which is equal to 5. That is equation 2. Now you can be able to solve for N as well as the M simultaneously. Either substitution method or elimination method, whatever it can be. So that's how you should have to understand about the addition and subtraction of the matrices and how we can apply the equivalent theorem and some practical questions. So try to practice more, and you'll be able to mastermind the concept behind. Thank you.